So, the past few times when I was streaming, um, not all the time, but once in a while, there would be an occasion where I would make a mistake, like not passing all the arguments to print or something like that. And then I would say, well, we used to catch that and we will in the future, but because I deprecated the way that was done, there used to be this thing called a check directive that I implemented during the first demo, or showed during the first demo. But that was superseded by the functionality of general compile time metaprogramming. So the policy has always been, well, we'll re-implement that stuff later in compile time metaprogramming. And I think we have come to the time where later is now, because why not, right? Why not do that stuff? All right, someone from Czech is saying they're going to sleep. Yeah, it's about that time over there. I've never been there. I've been to Croatia, that's close. Okay, the future is now. So, and I'm going to make this, because I'm a little bit thinking that this would be something that many people might want to use, I'm going to put this functionality into the so-called standard library, right? So, and it's going to not be super frameworky. It's going to just be like some leaf routines that you call from your program. All right, so let me just start there. So we're going to go to here. My keyboard keeps switching to Spanish somehow, and I don't know how that's happening. I don't know. So here we go, and well, I'm going to put some content in the file, and I'm going to add that so we don't forget. So what are we going to do? Things to do today. Check print state, or print like calls to ensure they have the proper number of arguments. Detect shadowed detect erroneous assignment or erroneous declaration of a new variable when we meant to assign it in a higher scope. Those are the two main things that I'm thinking of. Can anyone else anyone maybe who's seen some of the streams, think of anything else that I may have been doing? Any kind of compile time checkable error that I may have done many times? Anyone? Oh yeah, Shift and Alt changes keyboard language. But then isn't that going to change what some of the keys do and then make me unable to play if I use those keys? Something about double equal compiling. Oh, right. Yes. So the thing was just a statement like, so detect lone statements like A is equal to B semicolon and issue a warning. Yes. Syntax sugar for string interpolation. Someone is saying, no, that would be handled by a totally different feature that isn't implemented yet. And what I'm doing today is just catching errors. This is not about anything. This is not about implementing new language features. Someone says, why is A equals B a statement and not just an expression? Because any expression can be a statement. I mean, we could actually just do stuff like this. Also, A plus B, etc. Right? What about A equals B inside conditionals? I already explained this yesterday. So this is a common error in C++ and C and other languages where you say if A, you meant to say if A double equals B, right? And something, but you accidentally said that. That does not even parse here because equals is actually not an expression, right? So equals in C is an expression. Equals is a statement level operation here. So this, the compiler will actually complain about this. Or, anything like, anything like that or whatnot. But it won't complain about that. We discussed this on a stream yesterday, actually. Would it be good to check for a no warning note for suspicious code that is known and long standing? Yeah, you should probably enable, enable no warning notes. However, may not happen today simply because right now notes only go on declarations. And you kind of want to be able to put one on an arbitrary statement, right? Like for some reason, if I wanted my A double equals B to not warn me, I don't know why I'd want to do that, but maybe I'm using that for something. Maybe that's the output of a macro, and I'm just like, whatever, that happens sometimes, and I don't care because it has no side effects. Then, you want to be able to put that on an expression or a statement, and there's not a way to do that yet. Because they only parse at declaration level right now. So that would be a thing. Circular recursion. The problem is circular recursion is legitimate. And to detect whether or not it actually happens at runtime. I mean, you can detect very simple cases that aren't that useful. But to detect whether it actually happens, you need to solve the halting problem, right? And that's not good. To detect for the majority of cases, right? But that is, it's probably helpful to people to check for the simple case of like, look, there's no way to branch in either of these routines and they call each other and there's no exit condition. I'm going to put that as things for future though. Because that kind of check is, it's likely to catch a problem once every long while, right? And I want to implement things right now that are happening a lot. Because part of the goal, let me put this in, detect obvious circular recursion, or we could also put obvious infinite loops, which is not a thing that really ever happens for me either. So an example might be, for an infinite loop, you have like a while true, and there's no way in the body to break out, right? Of course, you might call exit in the middle of that loop. So like, well, maybe you wanted that. Part of what I'm trying to do, so first of all, I'm trying to catch errors. So I guarantee that if I implement, well, I don't 100% guarantee, but I mostly guarantee that if we implement all three of these things, and then I run them, we'll catch some errors in the Sokoban game already that are violating some of this. The print calls, there's got to be something that is wrong because I make that mistake so often. But the meta thing that I'm doing is I'm saying let's test out the language syntax and semantics a little bit. That every language syntax and every set of semantics has strong points and weak points, right? And so the weak points are, for example, of the colon equals declaration syntax has this weak spot, right? Where it's easy to declare a new variable that you meant to be an assignment, right? And so part of checking whether or not that is a good syntax for the final language is to see if we can actually catch that problem in the majority of cases, right? If we can, then or all cases, right? Or almost all cases. If we can, then the practicality of that problem becomes small, and then it's fine. If we can't, then it's maybe a sign that that wouldn't be a good syntax for the final language. So that's kind of what I'm looking to do is, fix things that have popped up that are, well, just common. I don't know. I'm repeating myself now. Structs using another struct with the same named member. That already is a compile time error because you get a namespace conflict. Unreachable return paths. Unreachable. You mean code in a block after a return or something? The compiler already says that, if that's what you meant. Fix anim developer. No, because we're doing... that would be a thing to do a different time. Right now we're doing general error checking. For loan, do you mean then in any scope neither A nor B are used? No, so a double equals like this has no side effects. So if you just have this in a statement, you probably meant to say A equals B or something, right? That's all. And if you say that, it's like, well, why did you say that? That doesn't do anything. So the fact that you said something that doesn't do anything means that you probably meant to say something else, right? Reassignment of variables used in defer. I'm going to put something to do with defer because I'm not sure that reassignment of variables. Oh, there's a thing like if you have a defer free and then you assign a variable later. Yeah, like. That one's a little bit tricky in the following way. What you really want to know, if you say defer free X, I don't think we want to care about arbitrary defer, but like defer free, for example, is a thing that you might do that's common. And I certainly have made that mistake a number of times, it's true. I make it less now that there's a temporary allocator where we don't explicitly free. The thing about this is that you need a general data flow analysis engine to really detect this in some case. I'm not even going to say all cases, because all cases is probably impossible, but there are cases where you need to know what's going on. I mean, I suppose we can detect if you obviously change X, then yeah, we can detect that. And if you take a pointer to X, we can say, you took a pointer to this, and so it may be changing, right? And that may be good enough for now for all practical purposes. And then, I have a feeling that later, whatever this grows into is going to have a general data flow engine, but I'm not going to try and do that today for sure. A return statement somewhere in a function that will never be reached. Well, if the return statement won't be reached, then the other things in the block won't be reached. So it would be more like generally detecting code that won't be reached, right? Procedures that are never used in the program. I think that's a different category of thing. I do think that we want to detect that. Let me put that in another module, detect dead code, because I'm pretty sure there's dead code in the Sokoban game now, and it would be nice to know what that is. But I feel like dead code detection is part of a different thing. It's part of a like a program analysis and statistics package that tells you things about what is going on. Whereas this is like just explicitly error messages about things you did wrong is what we're doing today. I mean, instead of, so somebody just suggested this, right, to fix this problem, defer free. I mean, you don't need to add a directive for that, right? Instead of saying that, you can just say defer A is X, free A, right? Wait, no, that's not true. You'd have to, no, you'd have to put the A equals X out here and defer free A, or whatever. I mean, but the problem is not that you don't have a way to express this. The problem is that you forget to do it, right? Or maybe initially when you write the code, you say defer free and it's correct. And then later on, you go and do something that modifies X, and then it becomes wrong. So, you know, we're not talking about implementing a way to do defer free simply. We're just talking about catching that error. Okay. I think it's going to start. All right. Don't you have to construct a graph to find unused functions, create a node for every function, refer to in main and recurse, then when you've done functions in the graph are unused? Yeah, that's basically what you would do. Yes. You know, it's a little bit more involved than that because you can have like, you know, variables that are function pointers and stuff. But yeah, that's the basic thing. And I actually already demoed something that mostly does that back when I did a different stream for compile time checks in this kind of metaprogramming where I implemented like the MISRA C, there are a few of the MISRA C rules that the automotive industry uses, and one of those was about looking for potential mutual recursion, which is illegal under that standard. And to find potential mutual recursion, you have to build a graph of the functions. So I already have some code that does that. So if I want to do dead code analysis, I can just pull that over and repurpose it. Someone says, what about general scoping variables to arbitrary scopes? I'm not sure what is being asked. What is my internet speed? I don't know, man. I just got some internet. It's pretty good, usually. Okay, I'm going to actually get started. So, go in Sokoban, source, and I'm going to say, I'm going to make a variable called, oh, we have a do code review. What? All right, let me look at what I have in here, because I haven't used this in a long time. Okay. Maybe code review is going to be a different thing, because code review is about how style. Do code review is about how style. Do error checking is about things that pretty much anyone would consider errors. And the reason I want to be able to turn this on and off is that it's going to affect compile speed, and if we don't want to pay for it, then we shouldn't have to have it. So, if do error checking import checks, I think we called it, Emacs, killing me. All right, let's just make sure that goes. Oh, it didn't. Huh? What? Wait. Why is that? Oh, it's check, not checks. All right. Let's get off LLVM for now. Too slow. All right. I'm not going to answer off-topic questions like Linux or what keyboard I use right now, because if I answer that kind of thing on a stream like this, then we never get done with the main point. So I can answer that kind of stuff on a different stream, or maybe after this one. Okay. So we're calling that thing, and so what does that mean? That means, well, let's look at how we implemented do code review, assuming it's still, no, I guess we're not calling that anymore. Well, okay. So here's our thing. We have this process build events, which is our loop, you know, where we wait for all our compiler messages. Let me delete that. You know what? Let's do this. So workspace 1 is going to be like our metaprogram workspace. That's the first thing that starts up. And then we make new workspaces for any build that we compile. So the reason I'm checking workspaces is greater than 1 is just because we want to do this stuff to the target program, right? Not this actual metaprogram itself. Oh, Emacs, you kill me. So we're just going to do that. We have to go bananas. We do that. So we have this kind of modular thing where we slot in our different routines. So this is our user level one that checks for stuff like registering console commands and key maps and whatnot. And go bananas, you've seen, if you've seen me do that kind of demo, and do profiling as if we're, you know, instrumenting the program with that kind of thing. And so, wait, what? 1, 2, 3, 4. We got one too many. So if do error checking, I'm just going to say do error checking on the message, right? And yeah. So then I'm going to go to here. So you can see the structure of what we're going to do. If you saw this earlier demo, you know, we get a compiler message, and based on what kind of thing it is, you know, we do stuff. So this is going to be called do error checking for now, because we don't worry about namespacing things yet. Well, all right. I think there's other legitimate reasons, since this comment was written for declarations to have null names, but I don't know. Like internally to the compiler, it's legitimate. I don't know if those make it out to user code, so I'm going to leave that comment there. Now, let me see. The longer that I have to think or not think, right? So here, we check for a procedure, right? So we cast for code type checked, we get the declaration just like we did here. Check for, we're going to do the print statements first. And there are a number of procedures that do print. So we're going to do it in a little bit of a special way. So we're going to do this. I'm going to see if it's a procedure body. if it's a procedure body for decl.notes, if it.text is equal to, we're going to have a special note called print like that says, look, this is essentially a print routine that has variable arguments and a format string, and the format string is going to be the last thing before the variable arguments, maybe always. Otherwise, our checker will get confused for now, and maybe we'll expand that later. All right, so check print like, right, of the declaration. So in file scope, check print like it's going to make this real easy to spot. Is that, let me see. I forget. Yeah, so this has, we're taking an argument that's one of these that gives us information about the declaration, and one of those is the name that's just stored as a string. So we're just getting up to this point, and right now I'm going to see if this compiles, and this will never fire anyway, because we're not tagging anything in the program as print like. Because we're not using that. How do I do that? What's it called? Using compiler message.kind. All right, well that compiled, and you don't see that ever, right? So let me make sure that, make sure it's turned on, right? Do error checking is turned on. So if I'm going to document these, I should document this one as well. Let me, since we're at a point where this compiles, oh boy, there were earlier changes that I didn't check in. Well, they're checked in now. Add hooks for always update. Didn't I say that yesterday? Look at all those code changes. Fortunately, no conflicts. All right. Yeah, last night while we were waiting for the PlayerUnknown Battlegrounds servers to update, I did a timer change and rename. If you saw yesterday's stream where I was thinking about how to do that, I just knuckled down and did that last night, and it touched a lot of files. Is there a way to specify through the notes which variable is the format string? Maybe. There isn't. Well, right now you would have to put it in the name, which we could do if we want to hack that together. Eventually, we're going to go from notes that are just strings to notes that are more structured and that take legitimate arguments and things like that, and then you could just have that be an argument. But for now, it would be a hacky thing, and so let's just see if we need it. If we don't need it today, then we won't do it, and if we do, then we will. Yeah, you can't add parameters to notes yet, but you will be able to eventually. Okay. Okay. So now, let me just go into here. And I'm going to say find the things, and I'm going to tag this as print like. I don't need a semicolon there. So print is print like, sprint is print like, tprint is print like, log print is print like, and the other lug print is print like. And this log print is also print like. And I think that's all of them. Yeah, and then I should put that stuff in file scope, right? Oh, maybe not. Maybe people want to call this stuff append struct info. I don't know. That feels like a file scope thing to me, but I'm not going to worry about it right now. Put this in file scope. Okay, so I don't like that because we just tagged things as print like and didn't see any print statements. So that I must have goofed. So let's just go way up here. Let's see if that ever fires. Yeah, okay, that fires. For really not as many declarations as I would have liked. Why? That's really a small subset of the number of declarations in the program. Wow, okay, if there's a big compiler bug preventing this from happening, wait, there's no way. There's no way, because so many things would fail to work if... Am I checking something else? All right, let's go back. Maybe the place I inserted this is not good. Wow. This is crazy. All right, we're just going to do this. Print. Well, first we'll go here. Gah. All right, this may derail the stream. Oh, I need to print the contents of the message. This may derail the stream. That's not that many messages. Wow. What is going on? Why are we not getting other messages? That is so weird. How does anything work? Let me put it out here. Maybe the workspace handle is not being initialized correctly. Well, it's still a totally tractable number of messages. Okay, well, wait. No, hold on. Okay, this is weird. So first of all, I feel like I should see more messages. But even ignoring that, I am getting the messages for print in there. Anyway, so, okay, let me do this to output.txt. Load just loads your own files, and import loads library files. I'm not really sure if it's going to be the same or different ultimately. It's just arbitrarily different right now. Print, log print, tprint, sprint, print. Oh, I might be only exporting things that have notes right now. That might be a flag that I set for compile speed. That might be why I might have implemented that a long time ago and then forgot. But that doesn't matter because we are getting the routines we want, right? So I'll investigate. I'm pretty sure that I made a flag for performance reasons where it's like, okay, only tell us the things that have notes. But these things have notes. So tprint, log print, and all that have notes. Let's try this. Like, well, those are there. All right. So let's figure out what I did here. We get lots of code type checked. And we get it for print, right? Maybe I'm just not setting this. Oh. Maybe the notes go on the procedure header right now, and the procedure body does not. Okay. Let me see. That would be confusing. I bet that's what's going on. This is what happens when I change things. So, so the flags for stuff like print are 1 and that just says it's constant. Okay, wait. Procedure header nor body are set. That's bad news. I can think of reasons why that's happening, but okay, one thing at a time. I did not intend for this to turn into a compiler debugging stream, but that's what it's becoming. So first, build options. Let's see if info flags. What's info flags? No, that's not. All right. So if we're going to do error checking, we're going to have to look for things that don't have notes anyway. So regardless of this whole other problem where these guys aren't flagged correctly as procedure bodies, I want to go for the wider problem of we need to see everybody anyway. So let's see. Intercepting code. This is confusing me. So we always export. Well, let's just do that. Let's re-enable this. And let's see how many guys we export. Whoops. Let's not build the debug compiler. Let's build the release compiler. Didn't. It got an error anyway. Emit. Okay. I guess I accidentally. Wow. That's a little bit scary, by the way. I might have totally broke the compiler. Now I'm scared. Because I was doing something where I was playing with eliminating constant storage data, and then I backed it out. And maybe some of that was still on this computer. Which means maybe I checked it in when it shouldn't have. So who knows? I may have just totally broken something else. Let's make sure Sokoban runs after I compile this. Ah, all right. Wow, okay, I may have totally toasted the compiler in a really bad way. I may have to revert parts of that previous. Remember when I did that check-in and all that other stuff went in, and I was like, oh, that's interesting. I may have to revert some of that. Well, yep. Okay. This is not only a compiler debugging stream. This is a super. Okay. So this is officially now not the runtime error messaging stream or the runtime error detection, compile time error detection stream. This is the debugging the compiler so that I can really do that stream later today or tomorrow stream is what this has become. So I need to go now look at this thing. So this one, no, not that one. This, no, this, wait. What? Oh, I'm in Sokoban. That's why I'm not seeing. I want to be in the compiler. I was like, I don't see that check-in because I'm not looking in the right place. Okay, here. Okay, so first of all, I'm going to go back to the command. Those changes I just did to start try and fix, and then we say revert changes from this revision, revert, and type table, revert changes from this revision, revert. That should be it. That should be it. So okay, so we fixed that. Now, so that Joshua does not get my buggy version of the compiler that I checked in 20 minutes ago, I'm going to turn off these messages. Fix erroneous check-in. Okay. we are back in the saddle here. Now, so this claims we're exporting 23,000 things, which seems about right. That seems fine to me. Let me only count. So if workspace handle is greater than 1, I only want to count the later workspaces. Yeah, similar number, smaller number, because the main program, or the compile time meta program is much smaller than the thing that we're compiling. But so we're exporting 21,000 top level, well, declarations. Let's make sure we're intercepting the whole time. So now it's just going to print 1 on the second one the whole time. So I want to make sure that we're not like somehow compiling before we set that we want to receive messages. Now, well, that's interesting. How do we set that? Intercepting messages. We're getting most of them. Wait, what was it called? Intercepting code. Oh, this is probably after the set after the preload. There's a thing called the preload that, you know, loads some stuff before the main compiler starts up, and it may be that. No, compiler begin intercept. Well, where do we call that? Compiler begin intercept. Aha, here we go. Skip declarations without notes. Ha, ha, ha. Ha, ha. Ha, 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 ha. Ha, ha. Okay. So, here's what we do. We say, need all declarations is false. If go bananas, then we need all declarations. And if do error checking, need all declarations is true, right? So, and then if need all declarations, then we do that, otherwise we do that. Maybe this isn't the compiler debugging stream. Maybe we're saved. Boy, I really feel sorry for anyone who came along and wants to see a coherent stream, or who watches this later on YouTube. Oh wait, you can't comment that. All right. Hey, that's many more messages. Unfortunately, well, maybe it's compiler debugging stream. Maybe it's metaprogram debugging stream. Oh, it's compiler debugging stream. Declarations were held for messaging but never released. That is not what you want to see if you want to work on user level code. Interesting. Interesting. Why does that happen? Why does that happen? Okay, but we're seeing, this is basically every top level declaration in the program. So that's good. But we do have some compiler debugging now still to go. It's so weird. Held for messaging. So basically, you know, there's a pipeline that all declarations go through. You know, they start, you know, they get parsed, and then they get their types figured out, and then they get sizes figured out of structs and stuff, and then they go through this messaging pipeline where they get sent to the user program. We wait on when the user program's done with them, and then they go to like building bytecode for the procedures, and then it goes to the back end. So sort of what's happening is the messaging part of that pipeline is not totally working, which does not, honestly, it does not surprise me too heavily. Let's see if that's a threading issue. So if I say dash no threads or no jobs. Okay, it still happens. So it's probably not a threading issue. Now, it's a little bit weird what happens. So the basic structure of how the user program interacts is we here we go. So, recall we have this loop and we wait for a message and blah, 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 right? Now, I don't ever acquire ownership of this message and then release it back to the compiler. So the way it's supposed to work is that whenever I call wait for message, whatever the last message that went to wait for message was, is now considered release, and the compiler can take it back and push it further through the pipeline to get bytecode built and whatever. For some reason, that's not working. And it can't really be a user code problem simply because, user code is supposed to be this fire and forget kind of thing. So, yeah, I don't see a way in which it can be a user code problem, so it must be a compiler code problem. Someone says I need Sugar Man. I probably do. Why did I set it true for Go Bananas and for error check? Now, Go Bananas is an old thing. So error check is the new thing that we're implementing. And Go Bananas is an old thing that is about program analysis, right? And so it wants to see everything in the program. Well, I'm not sure if it's a design problem. It might be. So this is one thing I'm tossing around in my head, that maybe we should make it so that user code needs to grab ownership of a message and then release it or whatever. But that's harder for people to deal with. And if you want people to be able to write really easy compile time meta programs, then maybe this is the right interface. So the question is it necessary for some reason to be more transactional about it or not? If it's not necessary, I'd rather have the simplest interface possible here. So yeah, okay, so this is meant to be called repeatedly from an external loop. So we break when the messages are remaining. So here's the outer loop that calls this, and it really is not doing anything. And not anything special. So yeah. So well, what we're going to do is just stop at this kind of a message and just see if we could see anything about why that happens. so much slower. All right. So what is current count? 365. That's not like dropping one on the floor accidentally. That's like there's 300 declarations we didn't get to. And why did we get here? We're in compiler pump report. What? This might just be old code somehow. Like the logic behind what should be done or not when we get here. So messages pending is true. It's 365, which we know. Yeah, so, you know, what I think it is there's just the whole loop in the compiler that does this kind of deciding of what phase of compilation we're in. So, you know, I explained before that declarations sort of flow through this pipe of various stages. And then there's a sort of outer management of that whole pipeline system that's like, well, where are we? Have we finished loading all our files, right? If so, then we want to notify the user program about that, right? Have we finished type checking everything? If so, we want to notify the user program about that, right? If we finish type checking everything and no new code has been added, then we can go define or complain about all the placeholders that aren't defined, or we can report undeclared identifiers, right? But you don't want to report that identifiers are undeclared if you haven't finished loading all your code, right? So all that kind of thing. And I often say that most of my effort is spent on complexity that C++ compilers don't even try to have. And this is the case here, right? This is all, like, this pipeline management thing is something that you wouldn't have in a programming language where you have strict order of declaration like C++, where, you know, you have to process things in order from top to bottom, right? The reason this is more complicated than that is because it handles things that are nonlinear. And so what happened is just this loop is complicated enough that sometimes when I change things, I get confused about what the repercussions are and or forget some. So let's see. So we're calling advanced phase. I don't think we want to advance phase. Well, okay, advanced phase doesn't mean strictly, definitely, it's more like maybe advance what phase of compilation we're in. So, I don't think, okay. So the confusion here is that the naming of this procedure is confusing. So I'm going to change. So it's called compiler pump report circular dependencies, because when I first wrote it, it was like, oh, it's time to report circular dependencies, and so set some stuff up and then call this other routine that reports circular dependencies down here somewhere. And that's not really what it does anymore. So regardless of fixing this bug or not, I'm unhappy with that. We're going to call it compiler detect progress and maybe report circular dependencies. And then the question is, Question is, why are we even calling that if we have messages pending? Did I have a good reason for that? I don't think I did. So if, well, let's go look at that more carefully for a second. So if we made any progress on any of the pipes, we don't do anything in here. So nothing mission critical really is happening. Cycle detection. Okay, so I think I'm just going to try this and see if there was some legit reason. Well, let's see down here. If not messages pending or JAWS pending. Oh, I can't do that in C++. Got to put another parenthesis. Just put this down there. I mean, it seems to me like I should be able to do this, but who knows? There might be a reason why I didn't do that, because it's complicated. Well, we exited without hitting the error, so maybe that's it. Well, we compiled. Wait. Nope. Unresolved symbol generated main. Okay, well, that's not good. So we fixed that part of the problem. Was that just a fluke? No, it's happening every time. We're not outputting main anymore. See how complicated compilers are? Let me get rid of all these prints for now, because those were definitely well into compiler debugging stream at this point. Let's get rid of that user level code. Whoa, wait, what? Okay. Okay, the print statements are causing the problem. Probably because of timing or something. What if I go to a file? No. Okay, that's crazy. That is crazy. Oh, compiler debugging. This is why when people ask, can I use the compiler yet? I say, no, it's not ready. Because things like this. Okay. Although, honestly, these kind of things don't happen very often anymore, which is why today I'm like, oh, I'll just sit down and do this stream of this other thing. Or, most streams have not run into this kind of problem, but I haven't done anything with this message system in a while, not since the demo at Reboot Develop in Croatia a few months ago. So that is why we're running into problems. All right, but we fixed that problem. However, it has revealed a new problem. Now, why? Why? So let me go back and look at this again. This thing that I skip, detect progress, and so forth. I mean, maybe the only real thing that I skipped well, We do this cycle breaking and detection here, but I believe okay, this is weird because I think this is a non-pipeline related bug because here we go. Here, when we're building the executable, which we do because we issue this command to run the linker. So we get here. We know that we want an executable, and I look up the program entry point, and we flag it as main. So the compiler thinks it is giving main to someone. So let me set a breakpoint there. If this isn't getting flagged for some reason, all right. So we're basically just checking that you didn't define main to be like 3 or whatever here, because that wouldn't be a very good main. You can't make it foreign, you can't make it polymorphic, you can't make main be a compile time only procedure. It has to have no arguments, it has to have no returns. Okay, so here we go. We get a lambda, which is just a fancy name for procedure. And its name is indeed main. So here in the x64, we're still using x64 output, right? Yes. Here in x64, you know, we're outputting. The reason we do this is to not conflict with libc right now, because we're still using libc to start the process, even though we have very few dependencies on it at this point. And so that enters through main, and so we rename our main to generated main, which is stupid, but it's the kind of thing you do when you're just getting by. Having print in a function that checks print may be bad. No, it's actually fine, because it's too, well, for many reasons. But so the metaprogram that is doing the checking is different from the program that's being checked anyway. So the print that is being used in both cases is actually completely separate compiled instances of print, which still, yeah. So the one that's in the metaprogram has completed compilation and is in bytecode, and we're running the bytecode. Whereas the one that we're checking has not completed compilation. You know, it's still in, it has just finished type checking, but we're running a different instance of it, so it actually should work fine. I mean, who knows? Maybe I made a really weird mistake somewhere, but in principle, that's why things are designed the way they are, so that there's a great deal of clarity about these things, and you don't run into that kind of problem. Why don't I have a dev version type thing so fellow developers can help? Mainly because it's probably more work to organize that right now than it's worth. Like, I would rather just focus and plow through all these kinds of problems and get it ready and then do a developer version. Like when it's, you know, when this kind of bug is totally squashed. All right. So Right, so we got here. I want to look for the other breakpoint. Whoa, wait, we're here twice. We're here twice. Let's set this breakpoint further down. Okay, so we never hit our other breakpoint. That's disturbing. Why didn't we hit our other breakpoint? Hopefully not because we did this already, because that would be bad, although that's possible. No, we didn't do it already. So really probably what it is that lambda did not get added. All right, so here I'm gonna approach this a different way. Since we know we didn't get there, well, let's put this back, since if for some reason we start getting there. Okay. So this is sort of the serial number identifier of this lambda, and we can check later well, let's go into obj_writer. Well, so in this emit code, we go through all this stuff, and we can put the breakpoint here actually. So basically, when things are completely compiled, we go here, and I want to say I want to make sure. What I suspect is that lambda is never getting here, right? So that's the most likely explanation. So we're going to say what happens, or when do we get there for that particular procedure? We don't. Okay. That's fine. That gives us even more information. So what I suspect is happening is that this, for some reason, the thing that I did that fixed that other problem about messages is causing us to exit compilation while this procedure is still in the pipe, which might make sense because it's going to be one of the last guys to get compiled because he depends on other people who depend on other people and so on, right? So main is never quite getting out of the pipe. So here's what I'm going to do is I'm just going to copy this address and I'm going to say and then we'll go here. No. We'll go right. So here we should only call this. So the rest of the compiler is fully pipelined where people are in parallel and go through all these different stages. But we only call emit code when we're totally done. It's like not pipelined in any way right now. So let me, well, that gets called by compile, which gets called by somewhere else. So let's just set a breakpoint there. Hey, we're there already. And let's look at this lambda. And we can look at where it is in the pipeline. So its header is in pipe run. Its body is in pipe run. Okay, that's bad. So that is bad. In fact, we should check an internal compiler error for that. So interp, do we have an interp? Yes. So interp arrow pipes. This is all the pipes, and pipe run is going to be this one, and it's got a lot of items in it, bro. Okay, this is bad. This is, everybody should leave pipe run. So for some reason, so it used to be that every cycle, where's our detect progress? Yeah. It used to be that every cycle we would call this detect progress, and that would mean that we would break cycles on pipe run and stuff, and pipe patch, and do all these things. And so now, we're not doing that, and stuff is ending up in the run pipe, which maybe needs cycles broken. That's a whole other thing that we could talk about sometime. Although I don't think so, because main, well, there's probably some other cycle that needs to be broken that main is waiting on. Main is probably not going to be in a cycle because I don't call it from anywhere else. So okay, if we get here, we are about to build an executable, so make sure that all the pipes are empty, otherwise we done goofed. So for I equals 0, I is less than pipe output C, I plus plus, if pipes I dot input dot items is greater than 0, report error, internal compiler error, pipe %s still has the items in its input queue, and that will be pipes I dot name. Maybe it's not called name. I don't know. Pipes I dot input dot items. Right. No, we are not in interp here. Okay. So. Report, oh yeah, that's on interp as well. Okay. Okay. Let's make sure that that happens. Yes, it does. Good, good, good. So now we could maybe Well, let's make sure this error message is right. So the pipe is the run pipe. And there's a bunch of items. It's a different number of items than before, I think. Maybe I'm misremembering the number. Anyway. This is weird. Because messages and jobs pending, neither of those is set to true. So this, for this particular call of this routine, this would have been called. So here's what I'm going to do. I want to know what this didn't do correctly. Or maybe if I call it down here, yeah, let's just do that. What didn't it do correctly, and why does printing print statements at user level matter to what it's doing? Okay, this is disturbing me now, because the number of items in the pipe, let's run this again. See how there's OX3C items? Let me go out of hex. There's 60 items right now, right? Let's run it again. And there's probably going to be a different number than 60. No, there are 60. Well, but it was different before. There was like 8 E items, which is a lot more than 60. So something a little bit non-deterministic is happening, which is bothering me because we should be running with no jobs, which should mean that we do the same thing every time. So that's a whole meta issue that is bugging me in the back of my mind. Okay, so this probably nobody will have made progress. Okay, we do have items in the run pipe. We're going to detect a cycle. We didn't detect a cycle. So we get to the run pipe again. Report undeclared identifiers. That didn't do anything. Oh, but now we're going to generate a compiler error. Items are stuck in queue run. Right? Yes. So why didn't that happen before, buddy? Okay, so that report circular dependencies will have outputted this. So as we see, there's main at the top. It's depending on dudes who are depending on dudes who are depending on, everyone is waiting on do switch to campaign for some reason. What that has anything to do with a switch statement, I have no idea. Or a print statement happening at, this is a really weirdo compiler bug, man. Everybody's waiting on that guy. He got dropped on the floor somehow. There's two problems. So first of all, why is this guy getting dropped on the floor? And second of all, why are we not reporting that things are stuck in the pipe? I mean, maybe we are and I somehow missed it, but I don't think so, because it wouldn't, if we reported an error legitimately, we would not attempt to do this compile step, and we do. Oh, let me make sure. So there are many things that bug me about this. What will I use now in Paint is getting remade into some 3D thing. It's a good question. I may have to write my own. Someone's saying if you open source the project, you could say that you only accept certain kind of commits until you're satisfied with the main code. No, because it takes more effort. Right now, it would take more effort to review things like that than the contributions would contribute for the most part. It's just not the kind of project this is, right? I would rather like hire people to work seriously on it for full time and do very high quality work and help get things done. Okay, so my first question is, why did this not fire? So the way I'm going to inspect that is I'm going to say static int, if interp workspace index is greater than 1, or workspace handle, static int cycle count equals 0, and cycle count, well, let's put this out here so that we can see it from, so this is just basically a thing that we count up, and I'm going to see, remember that I called this from our breakpoint, and from there I can see what the cycle count is. And if that's the same every time, so that now is 12. So the 12th time we call this, we've already have an error, right? Let me make sure my call stack is what I think it is. Yeah. So what I'm going to do is I'm going to give myself a line here. If I can set a breakpoint. And let me just make sure that it's 12. Whoops. No. Just make sure that it's 12 a couple times. Because like I said, there seems to be some non-determinacy happening. 23. Oh, you're kidding me. Let's run again. Oh, geez. So if it was the same number every time, then I could just break on that number and see why it didn't do what I expect. It's 12 again. We could do a thing where we hope it's usually 12 and try to debug that. This is kind of sucky. This is kind of sucky. 12, all right. So I'm going to put a breakpoint. Now, since if it's a weird bug, if it's like a timing related bug, and that's why the prints are causing problems, this breakpoint may also change that. I don't know why it would be a timing related bug, because we're not supposed to have jobs right now. So yeah. All right. So let's see. Okay, no, this is not. So we're going to get here again. Yeah. Okay, that time it wasn't 12 because there were things in the other pipes. Although now it's cycle 13 and we have stuff in the run pipe. So let's just see. Let's just see what happens. for educational purposes. Maybe someone has made progress. I don't think so. All right. Did we detect a cycle? Yes. All right. Oh, wait, we detected a cycle. Okay, no. Detecting a cycle does not mean that we're done. Oh, wait, did I, what? What is a cycle count? It's 9. So this is confusing because I made this variable called cycle count, and now we're detecting a cycle, but the meaning of the word cycle in both those cases is different. Ah, you're killing me. 11. Well, let's just keep trying. See if it's 12 or over. I mean, I could just set a breakpoint here every time and look for that condition. So the problem now, okay. The problem seems to be let's stop around 8. The problem seems to be that when we're breaking a cycle on the run pipe, well, no, I don't know. I don't understand. Maybe that has nothing to do with the problem. I'm just going to step through for a while. Okay, so here, our cycle count is 8. We have only items on the run pipe. I'm pretty sure that we're going to detect a cycle in the run pipe. So we did, we broke a cycle, so we return. And we don't return any kind of status code or Boolean or anything like that. All right, so we did that. Interesting. Okay, that's fine. So we decided we're done building source, right? So that should be true, yes. So now we're just looping. We're going to pump again. Going to skip all this. Going to skip all this. Go here. So flow pipes is going to go through all the pipes, and these pipes are all empty, so it's not going to do anything. So yeah, so we've still got 565 items in the run pipe, but we broke a cycle in the run pipe, which means that when we get here, well, when we get here and we handle the run pipe, this number should drop from 565 to something lower. Boom. Yes. Okay. So that's fine. So now we just reassess whether we changed, and this is redundant. We really should just check the run pipe here. I don't know why I'm doing all these pipes. It's probably old code. We want to be returning true. Yes, we do. So we did make progress. So we're still looping. This time, all right, we made more progress. What are we down to? We're down to 524. We made progress. We're down to 508. We're down to 492, 472, 446, 431, 411. So the run pipe is gradually draining. 375, 353, 332. I'm looking at this number here, right? 320. So what's going to happen is at some point this is going to stall out and not be able to get any lower. And that's when we engage the next round of cycle breaking, and then we'll just continue tracing from there. Uh-oh. It's only going down by 1. Oh, 2, 1. Conditions not changed. Let's just do that. What? Okay. Okay. That's fine. That's fine, because that gives us maybe a clue. I don't know. I don't know if that's really a clue to what's going on, but all right. Annoying, annoying, annoying. Now I've set so many breakpoints that, all right. So now we're down to 128. I don't see cycles broken. Okay, wait, message is pending false, job's pending false. Set next statement, go. Wait, why is it 0? Is this really the first time? No, it can't be. What? Oh, we're in workspace handle 1. Oh, no. I don't care about any of that. Okay, I'm so lost at this point. I've been setting breakpoints, and now I'm super confused. Okay, let's try again. That's what happens when I don't eat breakfast and I just start streaming. All right, so we're going to go there. No, that's not where we're going to go. We're going to go back to here again. All right. Okay. We're here again, and we got here in time. Let's look at our pipes again. Okay, not yet. Okay. Where's this breakpoint now? Oh, this is our error. Weird. All right. I'm just going to step forward from there again. Let's look at our pipes. Okay. No, really? Okay. Let's look at our pipes. Okay, that, I gotta step one more at least, right? No! Wow, what? What? This non-determinacy is bothering me heavily. Maybe I should just debug that. I'm gonna put that on the list. Debug pipe non-determinacy. Because that is a whole situation that I do not want to be happening. And it's making this a lot harder than it should be. Okay. But one thing at a time, I don't want to rat hole. Okay, so I'm just going to step forward from here again. Okay, we got items in the run pipe. We're breaking a cycle. We return. Right, we were just doing this, but I got confused. You know, I could set a breakpoint at setting the phase index to inferring, because that seems to always be the last thing that happens before this. Okay, so we pumped. We should be changed. Yeah. Okay. So now we're on 9. So I'm skipping forward now. So we broke another cycle. Skipping forward. We broke another cycle. Okay, but now we have 60 items, which seems to be the point at which we bottom out, right? So 60 down here. We did break a cycle, so we return. Okay, does this pipe say, why does this not say num cycles broken on it, first of all? That's bad, because that's how people know if we made progress, right? So let me, like, I should probably assert here that the num cycles broken is greater than 0. So the whole, the whole way that this compile time system proceeds is that we check what progress has been made on what pipe and so forth. And if that information is inconsistent, that could lead to bad behavior for sure. Not the non-deterministic behavior that I'm seeing, but bad behavior. The non-determinacy is probably, I would say it's an uninitialized variable, except we're in debug build, and uninitialized variables should be set to relatively consistent things. So I'm not sure what's going on there. So it shouldn't have messages or jobs pending. We're not waiting on anything. Okay. Okay, wait, this is super weird. Because, no, this is really simple. The thing is, we made progress. And then for some reason, so if we make progress, we come down here, and if we're advancing the phase, then it's fine. But okay, so if we make progress, okay, so what I want to do is here, I want to just check and see, or maybe, I mean, really, maybe just here. Like, maybe this procedure is going to return true or false. And if it says that it did something useful, then we don't need to advance the fate. No. No. Stuff is hard to think about. Certainly, if it says it did something useful, we don't want to get here. We don't want to just fall through and do this. So maybe here we check to see if anything changed. Now, in order to check to see if anything changed, this pipe has to tell us that something changed. And it doesn't, even though we broke a cycle. So that's if broken, assert pipe num cycle is broken is greater than 0. That's going to trip. And we'll fix that. Right, so, and maybe detect a cycle. Maybe detect a cycle should do it, or maybe the caller should do it. Okay. So we do this whole algorithm here. Well, it's actually breaking the cycle. So I don't understand why this if changed pipe num cycles broken plus. It's C++, so you have to use plus. Okay, let's get rid of this. Okay, so we still haven't fixed the problem that we're getting here, but we should be able to now, because if we look at the pipes, this pipe says it has broken a cycle. So it seems that if we made progress on a pipe, don't proceed to executable building. And actually, we should do that. Should do that up here. Right, so, I have this hacky check here. Okay. So this check just says, hey, is there anything on these pipes? It's just this code is really old right here. This was supposed to say, hey, we're not supposed to start building the executable if there's stuff in these couple of pipes. But really, this has to be a much more comprehensive check now. This was probably written like 2 years ago at least, or more. So basically, for I is less than pipe, we'll say everything through pipe run if has made progress in terp pipes I proceed is false, break if do not proceed return false. So something like that is more like what it should be. Hey, we didn't hit our thing. Hey, hey. All right. Release build. Release build. Hey, look, it built the program, and I can run the program. All right. Fix a bug in wherein we exited the pipeline too early and stuff like that. All right, folks. Here's what's going to happen. I'm hungry. I haven't eaten breakfast yet, and this was supposed to be the compile time error debugging stream, and it got diverted into the compiler debugging stream. So now the compiler has at least been debugged enough that I could plausibly go ahead and do that other stream. So I'm going to take a break. I'm going to get some breakfast, and maybe in an hour and a half or 2 hours or something, I'm going to do other things. I'm going to catch up on my email, and then we'll come back and do what we originally wanted to do. So thanks for coming by for now. Have a good afternoon. Have a good late night if you are in Eastern Europe. And I'll see you guys later.